Good afternoon, Mariam and Judith. Good evening, ladies. I wanted you guys to join one time to give me your number so that I can put you in a group, but you guys did not contact me. So the other paper, did you get graph papers? That's people to get graph papers. Did you get them? Even me, I did not carry one. No, I can't do that number. I want it. I was waiting for the other gentleman, but it seems like he's not coming. Okay, let us proceed. So our paper to discuss today is still this Waukesha paper. We are supposed to do you have logbooks? Guys, do you have logbooks?
Yeah.
How about smart calculators, FX911? You have calculators?
We have.
Okay. Now we are going to do number 13.
Yeah.
Can you see number 13? This one. This is for distribution. Eh? Now, first of all, I need you to go and press your calculator. Press mode twice. Mode. Has it brought SD? Have you pressed mode?
Yes.
Has it brought SD, standard deviation? Something like that.
Yes.
Then press it, which is 1, I think. Eh? Are you there? Have you pressed SD?
Yes.
Now shift 3. Wait. Have you pressed shift 3?
Yes.
What does it display? HUR. Right? Right?
Yes.
Okay. Now, this is what is happening on that calculator. P, you know this graph I'm drawing, the normal distribution curve. P reads from where you are. Reads from negative infinity up to where you are. This is probability of Z is equal to P. Then you have Chu. Chu reads like the table. Chu reads from 0 up to where you are. That is Chu of Z. Then lastly, you have R. R reads from where you are up to positive infinity. So anything beyond where you are is R. So this is R of Z. So having witnessed that, because you don't have tables, we are going to use calculators. And when you use a calculator, the answer you write calc. When you use a table, you write tab in brackets. So the question says, time taken by a milkman to deliver the main market in Kampala is normally distributed with a mean of 12 minutes. Standard deviation, sigma of 2 minutes. Find the probability the time it takes on a day is longer than 17 minutes. So probability of X is greater than 17 minutes. Have you heard of standardizing? Yeah? We are supposed to standardize this to Z by saying probability of Z is equal to X minus mu over sigma. This is called standardization, whereby mu is the mean, sigma is the 2, and then X is the value you're talking about at that instant. For example, that's 17. So I'll say probability of Z is going to be greater than 17 minus 12 divided by sigma, which is 2. This was Z2. And the Z ranges between -3 and +3, does not exceed there. Now, according to this solution, the answer here becomes what? Probability of Z is greater than 2.5. Now, you have to illustrate this relationship on the graph, which is the normal distribution curve. So you identify where 2.5 is estimated. Now, remember on this graph, it is symmetrical about the mean. Here it is 0. Sorry, let me get back to you briefly. Hello? Go. So I was saying, the normal distribution curve has a 0 symmetric about its middle. Now the positives are on this side. The negatives are on this side, just like on a number line. So positive 2.5, I can assume it is around there. Now the question has said probability of Z is greater. The reason why we standardize it's because the table cannot read big values beyond -3 and +3. So the value I was talking about was 17. So that's why we standardize it to condense it to 2.5. Now beyond 2.5, you shade this side. Now if you're using a calculator, you can either use R, or you can use Q, or you can use P. But it all depends on how you interpret the question. The most obvious answer, according to this number, is this Roman 3. So can we go back to our calculator? Are you still there where we have those options? The person who has just come in, can you press your calculator mode twice? Mode, and then press SD. Then we press Shift 3. Shift 3. And then we press, it has P to R. Let us start with the P. P is exactly going to give us the answer. So probability of Z is greater than 2.5 is equal to the probability from 2.5 less than Z up to positive infinity. That is P. Get me that answer. What answer does it display, guys? You press P, it will bring P of brackets, then insert 2.5, then close brackets and say equals. Hello?
So
What do you have, ladies?
0.99.
0.9.
0.99.
Impossible. You have pressed P. You have pressed P. Another one. Go back and press R. That answer is for P. I'm going to also show you the relevance of P. But let us first use R.
(6.21).
0.6 or 6.21?
6.21 exponent negative 3.
Correct. 6.21 exponent negative 3. Same as 0.00621. We have used the what? A calculator. So in brackets you say calc. Now let us try to use other methods. Probability of Z beyond 2.5 is the same as the total probability under the whole graph is 1. So I can say it's the same as 1 minus probability from negative infinity less than Z up to where you are, which is 2.5. Now, can you go back to the mode SD, then shift 3 until you reach where you have PQR. This time press P, don't press R. The other colleague who has just come in, do you have a calculator or a logbook?
Teacher, I have, but I'm not thinking.
Yes, I expect you not to be getting at all. What do you have?
I have a code.
You have a calc. Press mode. Mode twice. Has it brought SD?
Yes, teacher. Yes, teacher.
Press 1 for SD. Shift 3.
Shift what?
3. What do you see?
3 root of cube.
Impossible. Impossible. Which calculator are you having? It is impossible. What calculator are you having? Can you show me on the screen? Put your video on. Let me see the calc you have.
So I have Casio.
FX what?
FX 991 MS.
991 MS. Okay, let us do it again. Maybe it's a fake one, but let's try again. Mode. Mode. Have you pressed mode twice?
Yes, teacher.
Has it brought SD?
Yes, teacher.
Press SD is under what? 1?
Yes, teacher.
Press 1. Shift 3.
Shift 3.
Has it brought PQR? Yes, PQR.
Yes, teacher.
Now the first case, P reads from negative infinity up to where you are on this graph. Then Q reads from 0 up to where the number is you're dealing with. Then the last one is R. R reads from where you are up to positive infinity. So this question was saying probability of Z is greater than 2.5. And the first method I've used is to read from 2.5 and beyond. meaning from 2.5 up to positive what? Infinity. That's why I came up with this statement. Now, can you choose R? I'm first using R. You pick R. R is 3, I think, don't you?
Yes, teacher.
Press 3. Then press
R,
2.5.
2.5. I'm done.
We get 0. R equals
6.21 times 10 exponent negative 3.
that is the probability we are looking for. Now, Ojok, now the rest I think you all know how we are doing that. Ojok, you've just come in. I don't know whether you have a table or a calculator. Do you have a logbook? Ojoka? Do you have a logbook or a calculator? He's not responding. Guys, let us proceed to method 2. We want now to use P. Press again until you reach where P is, P2R is. Then where you have, you select P and put in 2.5. I want to hear the answer you're getting. In that case, the graph looks like this. This is 2.5. Now we are reading from this way up to here. But that's not what we want. We want this side I'm shading red. So the whole of it, which is 1, minus the whole of this from there up to here, which is negative infinity less than z less than 2.5. When you put in P, what does it give you? The first answer someone got last time.
0.99.
0.99 for the small places.
0.9938.
38, eh?
Exactly.
Yeah? Now, when you subtract, the answer must be 0.0062. Subtract. Is that the answer?
Yes.
Okay. Now the third method.
Yes.
Method 3. We are going to use Q. Okay. For method 3, because this is 2.5, and we want to read beyond it, we shall look for what is between 0.0, what is between 0 and 2.5. And because the whole of this side is halfway, the probability here will be 0.5. Therefore, the probability of Z beyond 2.5 will become 0.5, which is the half, minus probability between 0 less than Z less than 2.5. Calculator. Now, before you get a calculator, press Q and then substitute in 2.5 in Q. I want to hear the answer you're getting. It should be 0.49938.
$0.49.
0.4.
937.
93.
9379.
Now, when you subtract, what do you get?
$6.21 times 10 exponent negative 3.
Which is the same answer, okay? So there are those 3 options using a calculator. Besides having a calculator, you can use a table, but I told you Q reads like the table, eh? So if you had the table would have read for you this value. Then you would have said 0.5 minus the answer in the table, and you get that result. Okay? Now with that, I trust that you know how to deal with the calculator. So if you're ready, downloading that, let us go for Roman 2. When you're ready, let me know. Okay, are you ready? The second one says probability lying between 9 and 13. Now remember, this is X. And according to this X, you have to standardize it. Now this time around, we are standardizing both the 9 and the 13. So we shall have probability of X1 minus mu over sigma less than Z less than X2 minus mu over sigma. Okay? This will give me probability. X1 is 9 minus mu over sigma. Hey, sigma is what? No, let me substitute now. Nine minus, what is our mu? 12 over sigma, which is 2, is less than Z, less than 13 minus 12 over 2. This will give us probability. 9 minus 12, you get negative 3 over 2, less than Z, less than positive 1 over 2. Giving us probability between negative 1.5 less than Z less than 0.5. Now, this is a very interesting probability. Why? Because it is going to cut across. So it's going to come from negative 1.5 up to 0.5. So we want this area which is shaded. So to start with, because I've showed you all the different options, all of them can give us the answer. The first one, I can start with the 2. Why am I starting with the 2? Because 2 will read from negative 1.5 less than z less than 0, 0 is in the middle, plus probability of 0 less than z less than 0.5. Get me the first answer for 2. This time round, guys, one thing you should remember, the probability of a positive is the same as the probability of a negative. So when you're pressing, press 2, but put negative 1.5. Then we see the answer you get. Then after, when you press 2 again, you put 0.5. Then we see the answer we get.
For negative 1.5, we get 0.43319.
And then for 0.5,
For 0.5, we have 0.19146.
and you add, what answer do you get? So we have got the one from here up to here, plus from there up to there.
We get 0.62465.
Which is approximately 0.6247. We have used the what? Calc. Okay? That is method 1. We are going to check out method 2. Now for method 2 and 3, both of these ones require subtraction. The bigger probability minus the smaller probability. Okay? And how are we going to go about it? For method 2, we shall get probability from negative infinity less than z less than negative 1.5. But this one should come next. So we shall get probability from negative infinity less than z less than 0.5 minus probability from negative infinity less than z less than negative 1.5. So go and press P. But for P, we are going to put in 0.5, we get the answer. Then we get negative 1, press negative 1.5, don't miss the negative. Because we are reading the probability like this. From negative infinity, which is this way, you come up to here and stop. From negative infinity, you read up to here and stop. Okay? So the difference between here and there, this one minus that one. That's why we are subtracting. So can you get me those probabilities?
For 0.5, we have 0.69146.
And the other one?
Why?
The rest, you hear people in the background are asking, how come you guys are not giving answers? You don't have calculators. Your calculator has died way back.
We are calculating.
Hey, read me the probability using P for negative 1.5.
Oh man. 0.06681.
And you subtract.
Zero point 62465. 465.
Okay, still we are using a calc. Hope that is also okay. But I'm not telling you that in the exam you go and use all the three methods. I'm giving the three options for you to choose a better option. At least you should understand one. Don't be there when you can't do any of them. And if you want to have one clear option, then just get a log table. But the calculator gives you three options, including one from the log table. So, whatever you wish, you can have. Method 3. For method 3, I am going to have to use chew. But this is how chew is going to look like. No, I'm going to use R. Whereby R, remember, reads from where you are up to positive infinity. So to start with, we have negative 1.5, which is going to be, you read from negative 1.5, which will be the bigger probability, up to positive infinity. Then come and read from 0.5 beyond. You see that the clearly shaded part is this remaining area. So we subtract probability of negative 1.5 less than z less than 0 minus probability of negative of 0.5. This is less than positive infinity. Less than z less than positive infinity. What answer shall we attain? You are pressing now Q. So you put Q in the calc.
For negative 1.5, we have 0.43319.
0 point? It is impossible.
43319.
Wait. We are using R.
Q.
We are using R, not Q. You are using Q for you. R should be 0.9.
Okay.
That one is already here.
Negative 1.5, we have 0.93319.
And 0.5.
Zero 0.30854.
When you subtract, what answer do you get?
0.331 minus 0.62465.
625.
65.
Yeah.
No,
So you see that all the three methods we are getting the same what?
465.
Answers. Okay, now I'm going to use one method. The numbers I land on. Estimate the number of days during the year when he takes less than 10 minutes. Probability of X is less than 10 minutes. Going to be probability of 10 of Z less than 10 minus 12 over 2, which is probability of Z is less than -1. So this is going to be what? Whenever you have less than or greater than, those ones it is always better to just use automatically. Either P or Q. The one you see applicable. So -1 less than it is this way. So go and read probability using P. What answer do you get? Straight away it will give us the answer.
Um, 0.15866.
Using a color. But now that is just the probability of the days in the year. So they are saying, go ahead and find the number of days. So you said 0.15866 times the number of days in the year, 365. How many days are these?
I did it. 57.98.
57 point. So this is approximately
9 days.
58 days. So they are approximately 50 what? 8.
58.
Download.
Mm.
Are we there? We have number 14. Time is running. But let me hope the next teacher does not knock me out. Number 14 says, says a body of mass 4 kgs decreases its kinetic energy by, that is what we call a change in energy. Energy has changed by 42 joules. If its initial speed is 5, find its final speed. There is a theorem which states that the work energy theorem states that work done by the resultant force is equal to change in kinetic energy. So the change in kinetic energy is a half mv squared minus a half mu squared. This is equal to change in kinetic what? Energy. This will give me a half times 4 times v squared minus a half times 4 times u as what? 5 squared. The change is equal to 42. By 2 once, by 2, 2. By 2 once, by 2, 2. Shall get 2v squared minus 50 is equal to 42. V squared is equal to 50 plus 42. Then 2v squared will give us 92. When I divide both sides by 2, I'll get v squared is equal to 46. Huh? What do we get?
46.
We get
46.
So v is going to be square root of 46. And the answer is what? 6.78.
78.
Meters a second. So next time we shall deal with the J paper. Now part B says a rectangle when they don't tell you where the direction of the allocations are, you label them going anti-clockwise. So the rectangle will be A, B, C, and D. That is how we label going anti-clockwise. You label in that direction. Forces 9, 8, 3 act along DC. DC, the arrow you draw it from D to C. This is 9 newtons. Then CB, 8 newtons. Then BA, 3 newtons. Is that all? Nine, 8, 3. Meaning AD has no force. So to start with, to get the resultant, sum up the forces along the x-axis. We have a positive 9 and a negative 3, which gives us positive 6. Sum up the forces in the y. In the y, we have only 0 minus 8. 8 is going in the negative y-axis. So it will give us negative 8. So it will give us a positive 6 and a negative 8. So this is 8, this is 6. Then we draw a right angle triangle, and this is where the resultant force will be acting. We shall also get its magnitude and the angle. So the resultant force can be got from 6 squared plus 8 squared under the square root, giving us 36 plus 64 under the root. The answer is 100 newtons. They said find also the angle it makes with the DC. The angle it makes with the DC. DC is now, they assumed horizontal. So it's along this line. So find tan theta. Tan theta is 8 over 6. And the theta will be tan inverse of 8 over what? When you press the calculator, what do you get?
Three point one.
Huh?
53.13
53 degrees. But here you don't just conclude that 53.13. You say 53.13 below DC, because DC was horizontal. So our paper is done. Next, we shall have the paper from Wakiso. I don't know that you recall this paper. It's the one you have been doing. There's another paper from Jeb. It's the next paper we shall discuss. Send me WhatsApps and I add you to the Submath group. Okay, any questions? Okay, no questions, I've closed. I've added already a Jack. The rest also WhatsApp me on my line. And then I can be in position to send you, or we can be in position to consult ourselves and send papers right there. So have a lovely evening.